We have here with us Drew, who is going to talk about attacking web applications with JSTAP. Here's Drew.
Thank you, everyone. All right, so, my name's Drew, and I'm here to demo JSTAP. Now, this is a tool that I built for red teamers to attack web apps, okay? What it provides... Is it working out? Going once, going twice? How's that? Better? Not really? Okay, I'll just talk louder. Does that work? Going once, going twice? Yes, talk louder, okay. So it's got a JavaScript payload that you need to get into the application, and then the backend server that payload talks to, all right? And what this payload does is it attacks the client side of the application, all right? And it instruments it very heavily so that the red team can monitor what the user is doing in that application. It doesn't attack the server at all, okay? Now, the payload itself has two modes of operation, all right? You've got implant mode and trap mode, and the difference between these two modes is primarily in persistence. The implant mode assumes it's going to have persistence based on where the red team has implanted it, okay? They pop a shell on the web server, they add the payload directly to, say, the JavaScript of the application, okay? In trap mode, it assumes it does not have that, so it uses a technique called iframe traps to establish persistence. That's a little heavy. Maybe it's to extend the runtime greatly. You would use this as, say, maybe a cross-site scripting payload. So this screenshot is kind of an example of what the iframe trap technique is doing. The pink page is the landing page, the actual page with the vulnerability in the background. What you see in the foreground is the iframe. Okay, I've shrunk it down so you can kind of see what's going on. You stick the user somewhere else in the application that's more interesting in the iframe, okay? The problem you see here is that the address bar is matching the real location and not where the user thinks they are in the iframe, and that's very suspicious. So the next thing JSTAP does is with its instrumentation, it's monitoring where the user is in the iframe, the path, and it spoofs the address bar of the browser so it matches that. When this iframe is full, full page, takes up everything, it's a very compelling ruse. We'll see what that looks like. I gotta exit this. Okay, so we're gonna start with WordPress. Let me get my, of course I don't have my server running. And we're gonna grab this. That's our login. Real pain with self-signed certs. All right. Now, we have a vulnerable plugin in this application that has a reflected cross-site scripting vulnerability. That is our alert box popping, proving that JavaScript ran. We are going to swap that out for the JSTAP payload. All right, it's going to pull it in this little file here. Now, what you've seen is that the iframe trap has a start page. We forced the user to the login portal. You see that the address bar is matching the correct location for that, but that is not where the user is. Okay, they are still on this page with the vulnerability, so the payload has continued to run. Now, let's say we've emailed this user, supposedly as their boss, saying, hey, I need you to log in, add the new admin user who's starting next week. So they're going to follow instructions and jump in here. And here we are at the WordPress admin portal. We can hop over to users, and we will add our new admin as instructed. We'll set them as an admin. Now, we're going to pretend that I'm going to write down this generated password to give to this new user next week. And we'll go ahead and save that, and we see we now have 2 admin accounts. Let's go see what JSTAP saw here. Okay. What we have on the left is clients, okay? We only have one at the moment. You get a first time this client was seen, last time we received an update, get their IP, OS, their browser. You can set client-specific notes, okay, with this button. If you have a lot of clients, you're kind of researching what you've been able to loot from them, and you see something good, you can add it to the notes for that client. I'm not sure if you can see it, but there's a star and an X here. So you can kind of favorite this client and sort and filter this list with these controls. The X allows you to kill this client's session. So if they're filling you with garbage or nothing interesting, you can kill their session and we won't accept any more data from them. If you're getting overwhelmed with clients, you can disable all new client sessions up here in App Settings. But now we're going to select the client and start digging into a time series of events that JSTAP was able to monitor, okay? First, you see cookies, all right? Now, JSTAP is monitoring cookies, local storage, and session storage. The first time it sees a value in these, it will report it out. From that point on, JSTAP monitors those values, and if they ever change, it will report the new value of that. Now, WordPress does use cookies for authentication, but unfortunately, we can't steal it because they correctly set the cookie flags that blocks us from getting that, which is very sad. We are also scraping HTML of each page visited, which you can kind of pop open in the viewer here. Personally, I prefer to download it and just go view it in a nice code editor. We get records of URLs visited and screenshots, okay? So as they work their way through the application, we're screenshotting what they're doing. It's a great way of figuring out what the user role is and what kind of stuff are they doing. This first page is not a surprise because I forced them to that login page as their starting point. Now you see here user inputs, okay? So we were keylogging anything that they type into the application. Great reason to force them to the login portal, we have their creds. So we're gonna grab this. This is a good thing to throw into your client notes. So we got the password there. Now we see that the next thing happened is they visit a new page, WP admin, and we get the screenshot. So clearly they logged in successfully and they are an admin. And we go down a little bit further and they are going to the users page and we get a nice screenshot of the current list of users, which is not terribly interesting in this demo at the moment. But we do see that they're now going to the user new page. And we see a screenshot that it appears they're adding another user. Now, I'm going to drag this off to the side so we can keep an eye on it. All right? Because the next thing we get is a couple of keyboard inputs. All right? Right here. We see a username. It goes there. We see an email. So it appears that they're going down this form and filling out the required fields. And the next thing we know, they're on a different page. They're on the users list. And if we pop that open, we see there's now a second user. And they are also, if you look at this role, also an admin. So this is also probably something we want to save. Another admin account. The problem is we don't have the password for this account because our target who was running our payload did not type it. But if we're looking at this screenshot, we know they filled this form out. Now, I know WordPress, and I'm sure a lot of you know WordPress, but if this was a custom app I had never seen before, and I see a password section down there with a generate password and a hide button, it's pretty safe to assume there was a password here, right? And if our application showed that password to our target, it's probably in the HTML code, which we've been scraping. So if we go back up here to the code for the user new page, and let's go ahead and download that. Let's go take a peek. All right, this is a lot of HTML. I'm not going to read it. I don't even like HTML. We know that what we're interested in was down here, which is very close to a button with a label generate password. So let's just search for that button. And there's our button. And if we start poking around, we see data password right there. That is the password for our second admin account. Okay. Now, we're going to pivot to a different app real quick. WordPress is sort of static content. It's great at that. A lot of apps are much more dynamic than that. What you see changes on the page, right, dynamically without you refreshing. JavaScript is the language that makes that happen. It's sending network calls in the background, right? Data up to the server, retrieving new data, changing what you see dynamically. Now, the JavaScript language provides two main APIs for making these background network calls. There's the older XHR API and the newer Fetch API. Although a lot of devs love to use jQuery, it's everywhere. jQuery also, that library provides network communications. But if you dig under the hood of jQuery, deep down it's actually building on top of the XHR API. Now, the JavaScript language is pretty funky and has a lot of quirks, but there's two that are relevant to this next JSTAP feature set. One is that these two APIs are presented to developers like as if they're normal JavaScript objects, like any other developer-defined object. And the other is that JavaScript supports monkey patching, which means that JavaScript code can be rewritten at runtime by other JavaScript code, which means that something as dumb as a cross-site scripting payload can not only rewrite the client-side logic of your app, it can rewrite the network implementation underpinning it, which is not good. So let's get this other app running. This is a really basic one. That implements 3 different ways of making network calls, okay? XHR, fetch, and jQuery, okay? Just 3 different ways of reaching out to the server and just getting a different answer to this question. And there's a button to inject the JSTAP payload. But before we do that, we need to reconfigure the payload a little bit, all right? So this is a different app. Our iframe trap needs a different start page to be configured. This is the start page that we use for WordPress. And this is the one we're going to use for this. This is a single page app, so it's pretty easy to pick one. We're also going to turn on the monkey patch feature. This tells JSTAP on startup to seek out the XHR and fetch implementations in JavaScript and rewrite them to add the instrumentation. And then this feature, by default, JSTAP grabs a screenshot when the user navigates to a different page in the application, all right? This is a single page app, so the path never changes, so it wouldn't trigger another screenshot. This feature, what it does is, after an API call is made, it will delay some number of seconds and then grab milliseconds, and then grab another screenshot. It's kind of crude, but it's effective. So we're going to save this. And we will go ahead and inject this. And you see, we've basically refreshed the page. This is the iframe trap running in this app. We will make our XHR call, our fetch call, and our jQuery call. Now, you notice the app is still working. These API calls are making it to its server and coming back with answers. But if we go over to JSTAP, we now see a new client, okay? Now, we're going to select this, and right away we see something different. We have local storage, okay? This API uses an authentication token, which is very common. And they're often not sent as cookies. They are included in the request often as a header. And because of that, they need to be stored somewhere. That means JavaScript can get them. So we will be able to steal authorization tokens, all right? So I'm going to save this one. API key. Not a very good one, but. And then the rest of this is normal up until this XHR events, okay? Now, before the application makes the API call, it has to configure it, right? And we are adding instrumentation to those calls as well. So on the XHR open, we are grabbing the URL, the endpoint that this network call is going to go to. In this case, it's the XHR answer. And the method is a post. You know, it could be a get, a post, a lot of things, but it's usually one of either get or post. And we were grabbing the headers. Now, this is not an interesting header, but this one is. That's our auth header. Now, we've already stolen this token from storage, but it's also nice to catch it on the wire too. All right? Headers often are where those tokens are sent. Once the application that we're targeting has configured that API call, it's going to fling packets, right? It's going to send the data up to the server and hopefully get something back. JSTAP's going to pair those things together. So you get your API call. You have the request body on the left. You've got your response body on the right. So you can kind of see what data's flowing up and back. Okay? And then here's our delayed screenshot. You can see that the HTML was updated. It's a really basic example. Going down, we now see the fetch events. Okay? Now, the implementation in the payload for fetch and XHR modifications is very different. We're extracting the same kind of data so we can present it the same way in JSTAP. You've got your setup with the endpoints and the methods. You've got your headers. And, of course, you have the call itself. Okay? This one's definitely Vegemite for the response. And there's our screenshot. Now, if we go down here, we have a whole other series of XHR API events, but this one has a lot more headers. And if you look at the endpoint that this is going to, this is jQuery. jQuery answer is where this is being sent. So this is us intercepting jQuery-based network communications by tapping the underlying API, which is XHR in this case. So that's kind of all the loot we're going to pull out in this demo. We've now gone through all 2 of our clients. We've made our notes. Once you've kind of done this, what you can do is take all your client notes and you can fold them into one flat file and export them to take them with you, which is kind of nice. Now, from here, if you want to grab this code, this is up on this repo. All right, it's open source. You can do whatever you want with it. Just don't break the law. Various ways of contacting me. If you want to protect against this, right? If you're concerned about this being used against your applications, first of all, don't have cross-site scripting vulnerabilities. It's a great start. Keep the red team off your servers. I'm looking at you, Holto. Stay off the servers. Failing that, a great way of making it really, really hard to do malicious JavaScript in cross-site scripting vulnerabilities or in general, things that make my life living hell as a pen tester, content security policy. I mean, you can really knock my legs out from under me on weaponized payloads with that. This is a very exfiltration heavy payload, right? I need to steal data, either from the server, in this case from the client. I need to send it to a server I control. If you set a content security policy and the connect source directive, that's going to tell the browser where JavaScript's allowed to communicate. If my exfil server is not on that list, I'm not getting the data, right? That's a good start, and connect source follows the default source directive. So if you've just set direct source, that's going to block this exfiltration. I have had that happen in engagements and had to spend an extra day finding a way to exfil files out of the application itself. So it can really complicate matters. So with that, I got some time for questions, if anyone's got them. Yes, sir. What was that? Where frames can be embedded in. Okay, that's a great question. So first of all, that doesn't impact implant mode at all, right? This is just for the persistence technique. And it does rely on iframes. So iframe policies like that, like X frame origins or content security policies, great for this. They're traditionally looked at as ways of blocking clickjacking attacks, right? Clickjacking attacks come from other domains, right? So a very, very common configuration is an iframing policy that allows it from same origin or self only. Remember, that's the default for WordPress. And that does completely block clickjacking attacks, but it doesn't stop iframe traps. I'm actually about to publish a a policy blog that says you should take away all iframing because not only does it protect you against clickjacking, but from iframe traps, right? This is a pretty powerful technique for persisting a cross-site scripting payload. Most don't need a long time to run. If I got a tailored payload, split second's fine, but JSTAP's got to keep running or you're not going to get anything. So yeah, if you block all iframing, you would be protected, but that's not common. Yes, sir. I can't, I'm sorry.
Sorry, bookmark. The client bookmarks the site that they land on. Does it have the JSTAP URL or is it the iframe or is it the actual cleaned up version that you manipulated throughout?
I'm sorry, I still can't hear you.
When the client bookmarks the page, does the bookmark that is saved, does it have the JSTAP URL? Like, is it?
Oh, yes. So if it's a reflected cross-site scripting where it's actually in the parameters, in the URL, absolutely. If this was like a stored cross-site scripting where they stumble upon it when they're using the app, you probably would want to set the start page as that page so that as they come across it, the iframe trap takes over right then and there so it looks normal to them. It just depends on how you're using it. So I think a lot of red teamers who are not really into web app stuff might be more comfortable with implant mode. It's a lot easier, way less complex. The only difference really in feature parity is that in implant mode, XHR monkey patching doesn't work. Fetch does. I have spent endless hours trying to make this work, and I have not been able to. No one's complained yet, so to be continued, I guess, in the future if someone really needs that.
What JavaScript runtimes will this work in? Is it like Chromium? Have you done Electron apps? Like what runtimes are you successful in?
I've only run this in really Chrome and Firefox across multiple browsers and multiple OSs. It's really generic. Probably the most picky part would be the screenshotting, and that's the one piece I used an external library for. I'm using HTML to Canvas. So when you look at the payload code, my code's like really unobfuscated, lots of comments to say what's doing what. At the top is the compacted HTML to Canvas library. If you're wondering what that is and it looks sketchy, delete it. Go grab your own and add it. I don't care. Like, I'm not sneaking stuff in there. So, but yeah, it should be pretty generic. Holto?
How do you manage stored persistence at the end of your operation? Do you have a way that you track where you put things?
No, so it's not really persistence. It's just keeping that JavaScript running longer. It's actually really easy to escape that trap. Refresh the page, they're out. Highlight the address bar, hit enter, they're out. There's actually a self-destruct mechanism in it. If in the iframe trap, in the app, they click a link to another domain or something that's going to open another domain in that iframe, what would typically happen is the browser is going to block that, and it's going to throw up a lot of messages like scary hacker, iframing, terrible, terrible things. I'm paraphrasing. It's different between browsers. That would be very suspicious. The first thing, from JSTab's perspective, what that looks like is when something loads in the iframe trap, the first thing it does is try to reach down into it to re-instrument it. It will be blocked in that case. And if that's the case, it's very bad. So what it does is it looks at its prior known location in the iframe trap and reloads the entire page to that, which obliterates itself from memory. But to the user, what this looks like is I clicked a link, my page flashed, and my mouse is still over the link, and it didn't go anywhere. And human nature is if you tried something and it didn't work and it's really easy to retry again, they're just going to click it again, and that second time it works. And the payload's gone. And I'm out of time. So thank you, everyone.